Hello. This is the second video in a series describing how to write cores for the TS2060 and T20 hobby computer boards. In this video, I will describe how to generate a skeleton project for the T20 hobby computer board. The same process can be used to create a skeleton project for the TS2060 board. I have chosen the T20 hobby computer board because it is a bit simpler, and I will need this core for design verification and checkout of the boards when they arrive. Ensure your tray tables are stowed and your seat backs are in the upright and locked position, and let's get started. I will be using the eFinix Project Maker program as shown on the screen. This program is still a work in progress, but the major features will not change. I will now describe the various sections and features of the program. The frame in the upper left corner labeled Board Type is used to select between the TS2060 and the Hobby T20 board. The options are mutually exclusive, so only one may be selected at a time. Each of the boards requires some unique files for a given board, and these options tell the program which of the unique files are to be used. The memory initialization area tells the program that you want to use the peripheral that will allow the Pico that manages the SD card to initialize the SRAM on the board. There are three possible modes for initialization. The 2068 peripheral mode. This mode is used only on the TS2060 board. It allows the SRAM to be configured and also sets up the board for use as a peripheral board for the TS2068. Standalone without bus. This mode is used by both boards. For the TS2060 board, it allows initializing the SRAM but disables the bus buffers on the board. This configures the TS2060 board to operate as a standalone board with no connection to the bus buffers on the board. For the T20 hobby board, it allows initialization of the SRAM, and that is all. Standalone with bus. This mode is used only by the TS2060 board to allow it to be used as a standalone board, but enables the use of the bus buffers. The CPU area allows the user to select one of the available CPU cores. Note that the TI 9910 and Z180 cores are presently not available, and not all available cores have been tested. The useful peripherals area allows selection of various peripherals for your core. Mass Storage Pico Interface. This peripheral is used by the FPGA to communicate with the Pico that manages the SD card. It allows the core to send commands to access the SD card file system, read and set the RTC module if it's installed, and send commands to send and receive data from the Wi-Fi module, again, if it's installed. This peripheral is also used if you select the SRAM initialization option. Use USB. This peripheral is used to communicate with the Pico that manages the USB devices such as keyboard, mouse, and gamepad. Raw I2S. This peripheral contains the bare minimum functionality to send data to the stereo DAC. It does, however, include a small section that allows sending fixed test tones to the stereo DAC for testing. Dual AY8910. This peripheral has two AY8910 sound generator cores, as well as the raw I2S core. Text Mode Terminal. This peripheral provides 80-column text output capability to the VGA port. It is a modification of Grant Searle's terminal provided in his multi-comp package. Simple UART. Provides a simple asynchronous UART with programmable baud rates. There is no buffering or flow control provided. TI 9918 video. This is presently not available. Enhanced TS2068 video. This peripheral is probably only useful on the 2060 board. It provides a somewhat upgraded video engine that is compatible with the TS2068 video spec and outputs to the VGA connector. Z80 Memory Mapper. A simple implementation of the memory mapping scheme used by the Z180 processor. This may be useful for Z80-based projects. Project Path. The Project Path text box shows the current path to the user's project. The button with the 3 dashes allows browsing the file system to specify the folder where the project files will be placed. Note, this program will not allow you to overwrite an existing project, nor will it automatically create the folder. This behavior is designed to minimize destroying or corrupting existing projects. Entity name. The entity name box allows the user to type in the name of the design for the project. This will become the entity name in the main VHDL file. Make skeleton project. This button will become active once a project path is selected. When clicked, the program will make a skeleton project. The Messages area displays various status messages from the program. The Clear Messages button clears the message display. I will now demonstrate generating a skeleton project for the T20 hobby board. So first, we will, in the board type, select T20. In this particular case, I don't require the SRAM initialization, so we'll leave that unselected. I'm going to use a Z80 in this project. I do want access to the SD card mass storage, also the USB for the keyboard interface. I will require the raw I2S interface to test the stereo DAC. I want the text mode terminal for status output, and the Z80 memory mapper. Since I need to communicate with 512K of RAM, I will use that to allow mapping that in. Now, we will specify the project path in a directory that I've been using for testing. Again, this can be anywhere in your path. So we will we'll use a blank project that has already been blank folder that's already been made. So say OK. We'll enter the entity name, T20 test, and now we will make the skeleton project. Now we'll go to that directory and we'll look at the T20 test project. As you can see, we have subdirectories or subfolders that contain the keyboard SPI, which is for USB interfacing, the Pico SPI, which is the component that will interface with the SD card Pico, the raw I2S component, the T80, which is actually the Z80, the terminal, which again is the text mode terminal, and the Z180 MMU. We also have a project file for the eFinix tools and a Quartus 13 project for the Quartus tools. In addition, we have folders for the eHex to binary tool, which converts the ASCII hex bitstream file to a binary file for programming the FPGA. We also have the bin to VHD file that will be used when it's time to generate the firmware for the Z80 and the core. In addition to all of that, we have a components package, which essentially provides prototypes or definitions of the various components that we've imported. That's used in order to allow the main file and the VHDL compiler to know which components are being used and what their pinouts look like. So this has just been a brief explanation of how to generate a project using the eFinix Project Maker tool, and a brief explanation of the files that are generated and the subdirectories that are also generated in your particular project directory. The next video, we will actually start looking at opening up the project VHDL file in Quartus and learn how to start connecting all of the components together to actually make a useful core. So again, thank you very much, and stay tuned for the next video.